Now we'll take a look at L'Hopital's rule. This is by far going to be your best friend. It's another way of doing limits, and it's shorter and easier. Okay, so pay close attention. You'll love this, especially if you weren't paying attention in the limits one. So L'Hopital's rule. It's used for intermediate forms of infinity over infinity or 0 over 0. And all it says is take the derivative of the top and bottom and see if you get a determinate expression. This is a listening check. Underline L'Hopital's rule. Underline the title. If not, repeat the process until you do. So what we're going to do is actually going to take examples of things we've already done. I'm going to take one of each and do it using L'Hopital's rule. Alright, so the limit as x goes to negative 3 of x cubed plus 27 over x plus 3. So this is the factoring one. So plugging it in, plug in negative 3 in, you're going to get negative 27 plus 27 over negative 3 plus 3, which is 0, 0. So it's intermediate. So all it says is take the derivative of the top and bottom. So derivative of the top is going to be 3x squared. Derivative of the bottom is just 1. So the limit as x approaches negative 3 and plug in negative 3 where you see x is equal to 27. So you can see that that's the exact same answer as factoring. So L'Hopital rule, by far the quickest way to do it. Let's do a rationalizing one. So let's do that example. So the limit as x goes to 1 of 1 minus square root of x over x minus 1. Again, check that it's intermediate, so plug in 1. We're going to get 1 minus 1 over 1 minus 1, which is 0 over 0. And then take the limit, take the derivative of the top and the derivative of the bottom. So you're going to get negative 1 half x to the negative 1 half over 1. And then put that on the bottom, so you're going to get negative 1 over 2 square root of x. And then plug in 1. And you're going to get negative 1 half. And we're going to check our answer from our previous notes. Going to see that it's negative 1 half. Nice and easy, right? Yeah, this is my Christmas gift to you. Alright, the limit as x goes to 0 of 1 over 2 plus x minus 1 half over x. So this is a compound fraction one. So listening check, put a box around example 3. Make sure it's intermediate by plugging in 0. So you don't get 1 half minus 1 half over 0, which is 0, 0. Alright, take the derivative of the top. Alright, so we need low d high minus high d low over low squared. So low d, well, that negative 1 half is just going to be 0. So we're just taking 1 over 2 plus x. So low, which is 2 plus x, or the limit as x goes to 0. 2 plus x. Derivative of high, which is 0, minus high, 1, derivative of low, which is 1, all over low squared, 2 plus x squared, over the derivative of the bottom, which is 1. So this is equal to the limit as x goes to 0, and we're simplifying this to negative 1 over 2 plus x squared. Now plug in 0 for x, so you're going to get negative 1 over 2 squared, which is negative 1/4. Let's check our answer. And there it is, negative 1/4. Alright, let's do another example. So this one is infinite limit and rational functions. So the limit as x goes to infinity of x squared plus 3x plus 1 over x cubed minus 2. Again, make sure it's indeterminate. Again, this is going to be an infinity over infinity. So now you take the derivative of the top and derivative of the bottom. So limit as x goes to infinity of 2x plus 3 over 3x squared. That's still infinity over infinity. So what do we do if we take the derivative? Does it work? We keep doing it. We repeat the process until it does work. So now take the derivative again of top and bottom. So you're going to get 2. Oh, but if you weren't listening, you wrote that squared. Now you're going to have to cancel it out because you weren't listening. You pay attention. So 2. And then the bottom, which is 6x. So the limit as x goes to infinity, plug infinity in. What happens when you have a really big number on the bottom? I just simplified it. What happens when you have a really big number on the bottom? It goes to 0. Alright, so let's check. Yep, that's it. Alright, we'll do a couple more examples. This is a listening check. Color in 2 over 6x. Color in 2 over 6x. Remember this one, we already know it's going to be 1, right? So let's actually prove it using L'Hopital's rule. So take the derivative of the top, so limit as x goes to 0 of cosine x over 1 equals, and put in 0 now. Cosine of 0 is equal to 1. Look how quick this is. Man, if you don't pass this test now, I don't know what to do for you. Alright, example 6, last one. The limit as x goes to pi over 2, x minus pi over 2 over cosine x. I'm going to check that it's intermediate rather. So you get 0 over 0. Alright, so taking the derivative of the top, you're going to get 1. And then the derivative of the bottom is going to give you negative sine x. So I just put it on the top. So limit as x goes to pi over 2 over negative 1 of sine of pi over 2. Well, what's sine of pi over 2? It's 1. So negative 1 divided by 1 is negative 1. And that's it. Alright, so let's practice. Come back and take the test once again and pass it.